It is sometimes useful to be able to replicate an existing model part, for example, to recover from a breakage or to upgrade your model. Often the parts we want to replicate have complex shapes, and we may need a number of iterations to produce a workable part. In this video, I look at a possible replacement of the cockpit cover from a foam RC chuck glider to allow increased space for electrical components, as well as some likely changes within the fuselage itself. One might manually excavate the foam, but what would it take to create a printable replacement or an evolved shape to use in an upgrade? Given the complex shape, gathering enough dimensions is a challenge. Thankfully, FreeCAD allows you to import and scale images of the object to use as guides. For the cockpit cover, I photographed the top, front, sides, and base. The trick is to have the camera far enough away that the parallax is limited. Best to crop the image before you import it into the CAD package. In addition to photographs, it's also useful to take calipers to features of the object and record these dimensions. You just might need them in the future. The workflow in FreeCAD is, of course, create a new body and then use the file import facility to import the cropped images. If you double-click on the image, you'll get its properties and you can set its orientation to the various axes. At the bottom of the properties pop-up, there's a calibrate box. This is a bit of magic. Click on this and then draw a line between two known points on the image. Type in the dimensions that you want and the image will resize itself. Here's an example where I shifted the images to the back edge so that bodies you create are in front of the image when looking from the top or sides. Of the many possible approaches, I decided to switch over to the part workbench and start with primitive ellipsoid body. And then I iterated the attributes of that body while looking from different viewpoints. In this view, we can see that a portion of the ellipsoid is actually a fair match for the upper curve of the canopy. Switching to other views, we might eventually reach a point that we would consider close enough. It often helps to go into the view properties of the body and add some transparency so that the details of the image behind can be seen. We need to cut away portions of the ellipsoid that are not part of the cockpit. For this, I chose a polyline in a sketch that I traced out where the cockpit meets the fuselage. And then we can take that polyline and extrude it to form a cutting body. It always helps to double check the view through the body to the side image. And then we go back to the part workbench option to split apart the ellipsoid with that extruded polyline. And this results in two bodies. Some of my other YouTube videos give this process in detail. Once we've done the split, hide the unused slice, and let's see if we've got a fair match with the background image. It does kind of look like we captured its image. Now, we've got a solid body, and for our purposes, we're going to need to hollow this beastie out. The workflow in FreeCAD, again, is a variation of prior videos. Essentially, we want to use the draft workbench to make a copy or a clone of the cockpit slice. And then we want to scale the y-axis of that body slightly and then transform it downwards in the z so that we've got an offset. And then we can use a Boolean cut to cut that resized copy from the original, and then we'll get some sort of a shell out of it. Here's the result of that Boolean cut. We have a thinnish canopy shape. So it's time to see if this workflow has resulted in something that actually might fit the fuselage. We create an STL and we take it over to the slicer and set up to be printed with, in my choice, lightweight PLA. Given the shape, I decided to try and print it vertically with a bit of support at the base. I used my normal slicing settings for lightweight PLA in RC models. What I noticed was that it was messy trying to cut away the supports, and the other was that the shell was actually not all that thick. Clearly, it would need to be adapted so as to host magnets or pins or some other attachment mechanism to the fuselage. One criteria about how well we did was weight. The original foam came in at 5 grams. This printed version was 7.7 grams. Would this be an issue for your project? More to the point, how well does this printed part fit the fuselage? Well, there is a gap. I suspect this can be traced back to the side image of the canopy when I originally photographed it. The camera was not exactly at 90 degrees to the object, and it was a little bit close, so there was some parallax. My second observation comes from handling the printed copy. It's about 1.5 millimeters thick. Okay, it's stronger than I expected. It does have some flex. However, there's a rather minimum contact area with the fuselage. If I was going to tape it to the fuselage or adapt it minimally with magnetic support, I still might expect it to fatigue after a few cycles and need to be reprinted. So, a second iteration is needed. So, let's pull out the calipers and measure the offsets at several places along the way. Now, we need to apply this to CAD. Best idea. Before implementing a change like this, go back, save the CAD model to a new name, and apply the adjustments. We want to return to the original sketch with the polyline, and then we want to adjust those points to reflect the actual gaps that we measured. The other task is to thicken the canopy. Ostensibly, this should just be a matter of shifting the Z position downwards, as well as further reducing the Y-axis scaling in the inner body. The complication in my case is that the lower edges of the canopy are already beginning to turn in, and I needed to pay careful attention to that inner body, iterate a few times, and double check. Here's a preview of the thicker canopy in the CAD tool. Do we print it now and check the fit? The initial printing of the thin canopy was done vertically, and I kind of remember that required supports and an awful lot of fractious tidying. With a thicker canopy, I think I'm going to try printing that flat. My question is how well that lightweight PLA might print the upper portions of the canopy, which are getting very close to being flat. Here's a section in the CAD tool preview of that 6% gyroid infill that I tend to use. After printing, I can see that there are indeed thicker edges, especially at the leading and trailing edges, so it should be rather straightforward to adopt the design for something like magnetic attachments. The inner sealing of the canopy, well, okay, that's a bit rough, but who's going to see it? Comparing it with the original, there's certainly a lot more interior clearance. And, well, there is still a minimum gap with the fuselage, but a little bit of sanding or some further CAD tweaks could correct that. If we look at the weight, the thin canopy is just a couple of grams heavier than the original. However, the thicker canopy is a bit more than 5 grams heavier. Actually, I started this exercise thinking that lightweight PLA replicants would weigh less than the original foam. If your goal is really constrained by weight, then yeah, you probably want to go with that thinner canopy, even though it's a bit more fragile. In review, this is one possible workflow for replicating complex objects. What I noticed was that it pays to take a bit of time with the photographs. Take them from a distance and then crop. Really try for that 90 degrees. minor variations inevitably add to the number of iterations you're going to need later on during prototyping. Although FreeCAD lets you scale images, it's good to have a set of physical measurements of the object which you're trying to replicate. If nothing else, it forces you to actually observe the object. Replication is an iterative process, and it involves some speculation as to which CAD entities will get you there. Save often so that if your latest idea doesn't work, you can go back and try again. And lastly, there's a whole universe of physical feedback you get when you take time to print intermediate prototypes.